Okay, take out your calculator. Okay, gotta have that ready to go. Okay, we gotta keep a good pace today in class because tomorrow I want to move on to for me, one of the most exciting lessons to teach of the year. Tomorrow we start takes us 3 days, so I want to finish by Friday. So that's kind of where I want to be. Okay, let's just talk about what we did yesterday real quick. This says use the following table to determine an approximate area bounded beneath the function over the interval 0 to 20. 0 to 20. What does R sub 5 mean? Right-hand sum, 5 rectangles. If I'm going from 0 to 20 and I'm dividing it up into 5 rectangles, what's the width of each rectangle? 4. Any question how I computed 4? Okay. First interval, second, third, fourth, fifth. What is the height of the first rectangle? Why not 1? Because it's right hand. So it's 3 plus 6 plus 5 plus 4 plus 2. Easy peasy now, right? So I add this up. That's 6 and 11 makes 17. Plus 3 is 20, so I get 80. Do left hand on your own. Go. You're welcome. No worries. Another 30 seconds, we're going to talk about it. Five, four, three, two, one. Okay, somebody tell me what changes with left hand. Yeah, I'm not going to use it. I'm not going to start with 3. I'm going to start with 1. So it's the same thing as this. So it's 1 plus 6 plus 5 plus 4. But I don't, or I got the 3 in there as well, right? Well, what's the number that gets left off? 2 is the last one. So I got 7 and 11 is 18 plus 1 is 19. 4 times 19 is 76. Is that what you got? Yep. How do I do trapezoidal? So I get 78. So you see how we've taken what we've done in these previous couple days, and we're making it pretty quick now, aren't we? Okay? All right. So we got a couple more examples to do before we get to the calculator part. We will use our calculator a little bit on this one. It says approximate the area bounded between the curve f of x, negative x squared plus 16, the x-axis, and the y-axis in quadrant 1. If you were to start this, what would be the first thing you would do? You graph it. What does negative x squared plus 16 look like? It is an upside down parabola. Tell me something more. Where does it cross the x-axis? Negative 4 and positive 4. So notice that the problem does not tell us the boundary, does it? We need to discover the boundary. It says the area beneath this curve and in quadrant 1. So I'm only referencing this region right here. You see that? 0 to 4. How many intervals am I dividing it into? 5 intervals. What is going to be the width of each interval? 4 divided by 5. You always take the width of the interval and divide it by the number of rectangles. Okay. I have 4/5 times, what is the first number I plug in? What's that? Oh, I heard 0.8. Okay, I thought I heard something else. So I was like, okay, I'm trying to figure out where we're coming up with that. So if I divide this up, and I'm just gonna make a mark here. So this is not the graph, but just so we can understand it. So 0, and then I have 4/5, and after 4/5, I would have 8/5, and then I would have 12/5, 16/5, and finally 20/5, which is 4. So do you see how just writing that out helps me to see where I start and where I end? So I just went up by 4/5 every time. Now, for the sake of time, we're not going to calculate all of these. We'll simply write out, we start with f of 0 or f of 4/5. F of 4/5 plus f of 8/5 plus f of 12/5 plus f of 16/5 plus f of 4. Now, one way to check to see if you've made a mistake is I have 5 rectangles, so therefore I should have 5 terms that I'm adding up. If you have 6 in here, you know you made a mistake. So sometimes you guys have been asking, Mr. Gantz, did I do this right because I'm coming up with a different answer? The first thing I do is I count the number of things you've added up. If you have more than 5, you've made a mistake in that situation, sir.
I'm trying to remember, how did you get 4 again? What's 4? I did 4.
So do you see how the interval goes from 0 to 4?
Okay, so each time the numerator is this 0.
Yep. Okay. All right. This one can go quick. Talk with your peer. How is this one going to be similar to what we have, and how is it going to be different? Talk. Go. Five, four, three, two, one. How is it going to be similar?
You still have multiplied by 4/5.
Yeah, we still have the same width, right? The width does not change. Yeah, we have 4 values that are the same, right? What value do you pick up here? We pick up f of 0, and then we end with 16/5. Because it's the left hand, notice that if you move to the left hand here, you don't use the number 4, you use 16/5 as your last one. Is there any question how I did that? Okay. Then talk to your peer. See if you can figure out how you'd set up midpoint of 5. Take a minute, minute and a half. Talk through it. Go. Okay. Can anybody tell me where I start for the midpoint? Marissa? Yeah, so I look at the midpoint of that spot, and the midpoint is 2/5. So we start with f of 2/5. Notice how the width remains the same. Okay, notice how the width remains the same. What's the next one? Then it would be halfway in between 4/5 and 8/5, which is 6/5. Notice, what is the distance to go over from 2/5 to 6/5? 4/5. So we continue to do that. What's the next one going to be? Yeah, 10/5, otherwise known as 2, plus f of 14/5 and f of 18/5. Very good. And that will be the midpoint result.
Solving it exactly, we're just explain how we.
Yeah, I think we all know we could type in our calculator and add it up, right? But for the sake of time, we'd like to err on the side giving you time to practice in class if we have that time, as opposed to actually going through calculation. And trapezoidal of 5 would be easy. All we would have to do is just take your right hand of 5 and add it to your left hand of 5 and divide it by 2. It would be the average of those two. And so again, the geometry is that the right hand would be, in this case, an over or underestimation. Underestimation. Whereas the left hand would be over. The trapezoidal will average the two, and you can see how accurate that would be. And midpoint will also be much more accurate. Okay. All right. We've got 2 examples to think through yet. This one's going to be easy, and then the last one will be slightly more challenging. So what the AP exam is it's looking for 3 representations for you to be able to find your sums. On the last one, we actually had a function giving this value of negative x squared plus 16 is our function, and then you calculate from there. In this situation, we're given a table value. So those are the 2 different parts. And then the third different part is, in this situation, you should be able to use a graph as well. Now, it does work out that if you're given a linear graph, which means it's composed of all lines, you can actually come up with the exact value, which is kind of nice. So this one says to do right hand of 4, and we are going to go from the interval 0 to 120. You tell me where to start. What should I do? Rectangles, how many? 4, so the width is going to be? The width is 30. We take 120 and we divide it into 4 parts. We have 30. We look graphically at our representation. I will draw these in red. Okay. I evaluate the height at 0 or at 30. 30. Over or underestimation? Over. Height is 40. Over or underestimation? Over. That would be 80. Over or underestimation? Under. We just get 20 out of that. And then the last one is an overestimation. So you can see as we add those up, we have 120, and 120 is 240. 30 times 240, well, I know 3 times 24 is 72, so I'm going to go with 7,200. Question? See if you can produce the left hand on your own with your partner right now. Please try to come up with a value. Go. %% of people's results, I'm seeing that people are coming up with 4,200. Is that accurate? Okay, so 4,200. Which one is easier to compute at this point? Midpoint or trapezoidal? Trapezoidal, average the two. If we add them together, we get 11,400 divided by 2, 5,700. It turns out that in this situation, the trapezoidal is the exact amount. Okay? So, good question. The question is, how do we know that? If we look at one of the rectangles, the blue represents a right hand, the red represents the left hand, the trapezoidal is represented by the green. See how that's exact? Not always exact. If we have a linear function like this where it's all lines, then that works out to be exact in that situation. Okay. All right. So if you have not drawn on this graph yet, I would like you to draw for this part. This is where the confusion happens over the years. It is the midpoint. Where would I draw the height from in this situation? At 15, I would draw the height. Now, here's the confusion. Sometimes people, when they calculate the midpoint sum, they put the width as 15. Do you understand why they do it as 15? But the width is from 0 all the way over to 30. So the width is still 30. It's just we calculate the height at 15. What is the height at 15? So you can see that it is an overestimation there, but an underestimation there, isn't it? So the midpoint becomes a very accurate representation. So what is my first height? It is 20. Where do I evaluate the second height? 25. And as you draw up to this spot, that will be the height of the rectangle. And so then I move over to that side and over to that side. Can you see again we have an over and an underestimation? Those look like they should actually cancel each other out, shouldn't they? Yeah. So my height for the second one is 60. 60. Thank you, Ava. And then we've got 75. We evaluate the height. Very good. It looks like that's going to be a height of 50, which you can see those again offset one another. And then the last one will be evaluated at 105. And that's back to 60 again. Let's calculate this. Yes.
So everyone draws differently.
Yep.
Like you guys can see like Excel got like 70. So how do you know what to do?
Okay. So I'm not going to try to trick you on this part on the test. Okay. I won't try to, but I will say that sometimes people get confused. Thank you for raising that question because there are every year I grade the test, and I'm like, how do they miss that? And I forget to address it here. So, very good. The question is, how do we know where the exact middle is? And I'll show you. In a linear graph, it's not too tough because what's the height there? 20. What's the height there? 100. So if we go to the middle, it'll be halfway between 20 and 100. What's halfway between 20 and 100? 60. So that's where we draw the line to. See what I'm saying? Now, I've been forgiving where it's like, okay, people kind of draw a little bit to one side or the other. And I've had many examples before where it's like, okay, you know, we're just going to approximate. When it's linear, we can come up with exact. So the AP exam, they do give those kind of questions from time to time, and they expect that you do come up with 60 with that type of thinking. Does that make sense? That's how we can ensure that the height is 60, halfway between the top and the bottom. Better? Okay, we add it up. I get 80 and 110, which makes 190. 30 times 190 is a grand total of 5,700. The midpoint and the trapezoidal produce the same amounts. It is the exact amount. We good? Okay, Please make sure, and by the way, this is generally the highest scoring test of this semester. You guys do a good job with it. And the stuff that we do the next 3 days, it takes 3 days because it's like confusing. But by the time you get to day 3, you'll be like, oh, this really isn't that bad. But it just takes a while. 3 days to teach one skill. Take out your calculator. Please be on task as we're doing this because the calculator questions can drive me bonkers. Okay? Take out your calculator. And if you don't have your calculator, please make sure you're following along with somebody else because I'm teaching you something that you do not know yet how to do. Okay, here we are. We have the following problem. It says find the area bounded between the curve sine of x, the x-axis, over the interval 0 to pi. Can somebody tell me what do they remember about the graph of sine of x? Starts in the middle, goes up to 1, drops back down to 0, then down to, and then over to 0 again. How long does it take to do that? It takes 2 pi, because once around this unit circle is 2 pi. So what's it going to look like if we're only going from 0 to pi? It's just going to be that top half, right? So the graph of sine of x looks like this on the top half. The second half it would drop down below, but we're from 0 to pi. This is the region we're working with. Are there any questions about the region we're working with? Great. What I would like to do is I would like to find the right hand of 100, the left hand of 100, the midpoint of 100, and the trapezoidal sum of 100. This is a question you have on your test. 100 rectangles. Don't really want to just do that all manually by hand. Agreed? Let's find a way to use our technology to do this. I did a question similar to this in college. I couldn't remember the exact formula that the professor used all the time, but so maybe you're using the same. Maybe I created a different one. I don't really know, but we'll make it work. The first thing I want to start with is the width of each rectangle. What's the width of each rectangle? Very good. Pi, because that's the width of the interval, divided by 100. So the width is pi over 100. Are you okay with that? So what is the first spot at which I would evaluate the height? Pi over 100. And then the second spot would be 2 pi over 100. Okay? Now, and we would continue on 3 pi, 4 pi, 5 pi, right? Pi is the same as 100 pi over 100. Agreed? So what would be the spot before it? 99 pi over 100, and the spot before that, 98 pi over 100. So that's enough information to really give me an idea of where my first and last rectangles are and things of that nature. So we've got enough of a setup here. We know the first, we know the last. It's time to let our calculator do some work for us. And here's the command that we type into our calculator. It is as follows. Width times the sum of the sequence of, did you already write it down? Oh, sum of the sequence of, and we write y sub 1, comma, we type x, comma, we put our beginning, comma, we put our end, comma, and we put our width. Just remember, we don't actually want to add up 100 by hand, so we're going to use this as an option. Okay? So let's write out what we are going to actually enter in our calculator for the right hand. This is our width. times the sum. Then we have sequence. Then we have y sub 1. Then we write x. I will pause to make sure everybody's okay with what I have there so far. Everybody good with that? Okay, what is the first spot which we evaluate the height? So that's what you put next, is the beginning is pi over 100 for the right hand. Well, we're going to do all four, but I'll show you a way to make it quick and easy, okay? All right, where's the last spot for the right hand that we evaluate the height? 100 pi over 100, or otherwise just pi. You can just write it as pi. So what you're telling your calculators, you're telling it start at pi over 100, end at pi, and each time go over one width each time. So that's why you got to tell the width here, which is obviously pi over 100. Okay, calculator out. Y equals. Clear? Enter your function. What is the function? Sine of x. Some of you borrow your calculators to those who are not in calculus class. So let us make sure that we are working not in degrees, but in radians. Does that sound like a good idea? Remember how to check that? Mode. I'm working in radians. Please make sure you're working in radians. Was there anybody that was sitting in degrees? Nobody? Okay. All right, we entered our function into y equals. Now, if you quit, we're going to enter this command. Better? You're good. You're good. Oh, second quit.
Oh.
Yeah, you just quit. There you go. Okay, pi over 100. Second, pi. Over 100. How do I grab the sum command? I go into my catalog. That's the yellow, so you go second, catalog. What do you think I do to jump to the S's? You press S. S is the LN key. You can see the green S right there. And I scroll down until I see sum. There are two sum options, I believe. Lowercase sum, and nope, there's just the lowercase sum. There I have it. You could have pressed T instead and then gone back one. That would have been a quicker option. I press enter on sum. Everybody okay? All right, I need sequence. I'm going to do the same option. Second, catalog. I press S for sequence. I go down till I get, there are two options. You want the smaller case option. Don't worry about it. I actually can't remember. And by the way, you only will need to do this once for each problem. You don't have to do it every time. I'll show you how to get around that. Is everybody okay with that? Okay, now we need to grab y sub 1. If you wanted to just enter sine of x at this point, you could, but sometimes the equations are a little bit longer, so I like to just enter whatever y sub 1 is. So here's how I grab y sub 1. This is the last thing that's complicated, okay? Press vars for variables. And this is something that we use later on during the year, which is why I'm showing you it right now. And I go over to my y vars. And I want the function variables for my y variables. And I'm simply just going to grab 1. Okay. Yep. Vars, y vars.
Oh, I didn't see
enter on function, and enter on y sub 1.
Okay.
Is everybody okay there? Vars. Vars. So I'll show you again. So I go, if I went to vars, I go over to my y vars, and I grab the function one. So I press enter on y sub 1. Okay, that's the most challenging part. Now you press comma. Comma is right above the 7. What do we press after comma? We press X. That was easy. What's next? Comma. What's next? So I go pi divided by 100, comma. Nope. Then pi, comma, and then pi divided by 100. If you want to press enter at this point, you can, but after you press enter, do not press anything else. I just want to make sure people can see what I have in case anybody else has questions. Can I press enter now? I press enter, and we will write it out to 6 decimal places. You can see it takes a while for your calculator to think. And I get 1.99983. 5. Anybody want to guess what the actual area is? It's exactly 2. So you can see it's getting a pretty close approximation, isn't it? Okay. Don't touch your calculator. We're going to use that, okay? Otherwise, you're going to have to re-enter everything. Let's write down the left hand. We start with the same thing, pi over 100 times the sum of the sequence of y1. What goes next? X. When we do the left hand, where will we start? 0. Where will we end? 99 pi over 100. And what is the width of each rectangle? It's still pi over 100. So notice all we have to change was our beginning and our end. So watch this really cool option with your calculator. If I want to bring up this answer, I would go second answer. But I want to bring up this entry, so I just go second entry. It pulls it all back. So I don't have to replace the pi over 100. I don't have to replace the sum or the sequence or the y1. I'm just going to go to this pi over 100 spot right here. And it looks like we're going to start with 0, comma. And then I've got 99 pi over 100. And then I've got pi over 100. Yeah. Just start typing it, so 0, comma, and then just continue right over it. Continue right over it. Ready? I press enter. 1.9988. What? 49. Great. So again, you can see we're pretty close. These are the numbers that I'm looking for on your test. The trapezoidal one's going to be easy, right? So let's end with the midpoint one, and then the trapezoid will be easy. Pi over 100 times the sum of the sequence. I start with y1, then x, and now we have to talk about the beginning. Talk to the person next to you. Do you know where we start? Take 15 seconds, talk about where we start. Go. Halfway between those. Yeah. Okay, here you go. What'd you come up with? Sure, 0.5 pi over 100. I'm going to write it like this. If you take 0 plus pi over 100 and divide it by 2, you get pi over 100 divided by 2, otherwise known as pi over 200. That makes sense to everybody? That would be pi over 200. Okay? Because you would multiply by the reciprocal. So I start with pi over 200. If you wrote it as 0.5 pi over 100, that would be acceptable. But pi over 200 is what I'm going to write. Again, the way we calculate the midpoint is we add them and divide by 2. So I get 199 pi over 100 divided by 2. Anybody want to guess what 199 pi over 100 divided by 2 is? 199 pi over 200. And then I go, our width is still pi over 100. Our width does not change. People sometimes change it on the test. Don't change it. The width is the same. Okay, I didn't calculate anything here because I want to bring this back. How do I bring this back so I have to retype everything? Second entry. And now I can just go back to my beginning. Instead of 0, I've got that pi over 200, comma, 199 pi over 200, and pi over 100. Oh, I did. That completes this lesson. You are ready to finish this worksheet. On your worksheet, if you're asked to add up 50 or 100 rectangles, use your calculator. Don't do it by hand. Okay? Yep, have fun with your kids. Good luck, Miss Netzer. Ava, you want a picture of this screen? Okay. You're welcome.